So to start, about coronaviruses. Now, I'm a visual person, and this is kind of hard for me to do virtual teaching if any of you guys have done it. So I'm just going to pretend that I'm sitting next to you, and on my piece of paper, I'm going to draw out some of the things I'm talking about. So a coronavirus is an enveloped virus, which means that it has kind of like the same part that's outside your cell, the cell membrane. It has a virus membrane, and that makes the outside part. Coming out of that membrane are these projections that we call spike proteins. And sometimes we refer to spike proteins just by the letter S. And that's one of the main components of a coronavirus. And actually, it's where it gets its name, because back in the day when they used to look at coronavirus particles under electron microscopy, so when you look really, really closely at them, what they could see were these spike proteins coming out around, and they reminded them of the corona of the sun, which you might be able to tell yourself. So that's where they got the name coronavirus. Fun fact, sorry, you know I'm a nerd. So inside the coronavirus particle is where you have your nucleic acid. And in the case of a coronavirus, that nucleic acid is RNA. And near that nucleic acid is another one of the viral proteins called nucleocapsid, kind of like the nucleus of a cell, where the nucleic acid, it's nucleocapsid, and that's also called N. And those are some of the proteins that I've heard come up in the media, and so I wanted to make sure you understood what those were. There are other viral proteins like an envelope protein and a membrane protein, but I'm not going to go into all of those. Just the big one is especially this spike. And now the spike is especially important because it's what helps a virus get into the cell. So if this is the virus, and then if this is a human cell down here, and this is definitely not a diagram that's going to be to scale. This spike protein is what helps the virus get into the cell. It's kind of like the key that unlocks the door to get into the cell. So the spike protein comes and it can bind that receptor. For the case of SARS coronavirus type 2, it's the ACE2 receptor. And then once it gets into the cell, and I'm going to skip the parts where the membranes fuse and everything, it can deliver that nucleic acid. So that viral nucleic acid can get into the cell. And then from that nucleic acid, it's actually that RNA, remember, and we refer to it as a plus strand RNA or a positive sense RNA, because from that, you can make proteins directly. You can also start to replicate and make more of the RNA itself. And basically what will happen, and this is extremely simplified and definitely not to scale, is more of these virions will be produced and you'll end up getting more coronaviruses. So that's the basic life cycle. And that's why you can see why that spike protein is so important. Now that's the actual virus itself. What about the disease? So the disease caused by SARS coronavirus type 2 is referred to as COVID-19. That's why there's kind of two different names. One is the virus and one is the disease. And so what we know about the disease is actually pretty similar to what went on with the first SARS virus, in that there's a couple different phases. So I'm going to draw a graph. Again, try to hang with me here. What I'm going to do here is this is going to be time on the bottom. So time going forward. And this beginning is when you first start to notice that you're having some symptoms. So when you first start noticing you're having symptoms is actually when you start to have a lot of the virus. So you have a lot of that coronavirus in your nose and in your body. And eventually your immune system responds and is able to bring that virus level down. And that's what it's supposed to do. And that's what goes on with most infections. So the virus goes up and then your immune system responds and can fight off the virus. And in most cases, if it's a mild infection, that's what will happen. You'll have clinical disease, and then the disease symptoms will go away. Your COVID-19 symptoms will go away as your virus goes away.